guys, Mrs. Heidenreich here, your favorite math teacher, and I'm here to tell you today about systems of equations. So first of all, what is a system of equations? A system is another word for a set. So if you've got a system of equations, that's a set of multiple equations. And usually when we try to solve just one equation, we're trying to find a value for the variable that makes the equation true. So if we have a set of equations and we're trying to solve that whole system, then we're trying to find the set of values or the value of the variable or variables that would make all of the equations true. And there's more than one way to do this, just like there's more than one way to solve an equation. Okay, but I'm going to show you really quick here some graphs of what solving a system might look like. There's more than one possibility depending on the types of equations that you're given. Okay, so let me pull up. There we go, now we got it working. Okay, so let's say that we have a quadratic equation. A lot of the ones you'll be looking at in your lessons have a quadratic equation, which ends up being a parabola when you graph it. So maybe you graph your parabola and it looks something like this. Okay, parabolas have a very special shape, so that's why I graphed it this way. My graph looks a little fuzzy because I'm using my mouse. Okay, so there's my parabola, and then I'm going to graph a line and show you some different ways that I could cross through that. Okay, so let's say, I'll get a green here, that my line is just regular old y equals x. That looks like this. And if I draw my line through that, for that system of two equations, which I've graphed, I am not crossing or intersecting between the graphs at all. So for this system, there would be no solutions. So you can find the solution to a system on the graph of the system. So you would graph both equations on the same graph and find where they cross. So it doesn't matter if it's a parabola and a line, two lines, two parabolas, you can do this and find how many solutions there are. But it is possible for there to be no solutions, for the graphs to not cross anywhere. Now let's say that I graphed my parabola and I had a different line that I wanted to see if I could solve this system and get a solution. And let's say that that line actually did cross, and it crossed right here, but the slope of the line is actually 1/2, so I'm going to do that and then draw my line. That line is what we call tangent to the parabola. It does cross at that one specific point. But it just touches it at that one point. So for this one, there's actually one solution. So it's possible to get just one solution if you've got a quadratic equation and a linear equation. Okay, and I think you know where I'm going with this last one. If I go ahead and graph my parabola, and it's supposed to fill in all the way, but my mouse isn't working totally right. And then if I graph a line, maybe this time I graph my line and it goes through, well, let's just say it's even flat. It could go through flat, could go through diagonal, but let's say my line goes through like this. This is the line y equals 3. That would cross at 2 points, so there are two solutions. And the place that we find the solution is where the two graphs cross. So let me just highlight it for you on this last one. This one has two solutions. One is at -1, 3. That's this point right here. The other one is at 1, 3. Okay. And if I had my two equations, I could go and plug in these two numbers for x and y, and then my two equations would both be true. I could also go to my two equations and plug in the numbers 1 for x and 3 for y, and then I would get a true equation for both of these situations. Okay, so that's it for what a system is. Now we're going to learn a little more in the next video about how to exactly solve one.